This is obviously a quadratic equation because it starts with an x squared. It has an x squared in it. That's what makes it a quadratic equation. And it isn't factorable because if in order to factor it, since this AC is 22, you'd need two numbers that would multiply to 22, but when you combine them would give you 10. And the only numbers that multiply to 22 are either 1 and 22, which adds up to 23, or 2 and 11, which adds up to 13. There's nothing that just adds up to 6. So therefore, we're stuck with this is not factorable, and we'd like to solve this. And I'd like to go through the steps of the completing the square again, all the way from the beginning to the end. When we want to solve an equation, a quadratic equation by completing the square, we have to make sure that we have only the terms with x's on the left side, and anything that has no x in this, and any constant term has to be brought to the other side. So I'm going to take this 22, and I'm going to subtract it, so that I end up with x squared plus 10x equaling negative 22. Now notice I did leave a space here. And the reason I left a space here is because I'm going to fill this in. I'm going to fill this in with a number that will make this side, if I add it, I'll have a trinomial that's a perfect square of a binomial. And the way we do it is we take half of the coefficient of the x, which is a plus 5, and we multiply and we square it. 5 times 5 thank you, Tashana. 5 times 5 will give me 25. So I have to add 25 to both sides of this equation. And that makes this expression in factored form. This is now a perfect square. It's x plus 5 squared. In other words, it's very easy. You're going to, your first term is always going to be the square root of the x squared, which is just the x or whatever variable you're using. The second term will always be half of this number. So the same process that allows you to figure out what this 25 is also gives you the number that goes into the parentheses. In other words, x plus 5 squared, the x squared plus 10x plus 25 in factored form is x plus 5 squared. Well, let's see what we have on the other side. So we combine. We have a negative 22, and now we add this 25. Remember, whatever we add to one side, we've got to add to the other side to keep the balance. So now this side is 3. And now we can take the square root of both sides to get rid of this square. When we take the square root of x plus 5 squared, all we're left with is the x plus 5. On the other side, we're left with plus or minus the square root of this number, which in this case is 3. If I can simplify that square root, then of course I do it, but the square root of 3 can't be simplified any further. But I'm still not finished because I want to get what x is. So I have to bring this 5 over here to the other side. So I'm going to subtract 5 from both sides. I always put the number that I'm bringing over, I always put that as the first term. So this will give me -5 plus or minus square root of 3. And this is our answer in simplest radical form. -5 plus or minus square root of 3. You could also write it separately. You could have written it as -5 plus radical 3 for one answer, and -5 minus radical 3 as your other answer. If you wanted to write it separately, this is like a shorthand of writing one you do with a plus and one you do with a minus. And that's basically where we had left off on Thursday, with having figured out how to solve these quadratic equations that I couldn't necessarily factor, but it still is solvable. Going a step further, let me take my calculator, because for this I might need a calculator. Sometimes you will see in your instructions. Okay, the smile, yes, please. I see you have your hand raised. How can I help you?
Yeah, I want to ask if you could solve a question for me.
I'm sorry, if I can solve a question from?
One of the questions from Delta Math, I was having trouble.
Okay, you know what? Wait 1 minute. I want to still say something more about this, and then I will do that question for you.
All right, sounds good.
Yeah, okay. So we ended off with two answers. One answer was -5 plus radical 3. And another answer was -5. I'm sorry, -5 minus radical 3. As I said, these are answers in radical form. Now, occasionally, not too often, but occasionally, more likely when you might have to do this for a science class, where they wouldn't want the answer just in radical form, but they might ask you something like that. Find your solution to the nearest, let's say, 10th. What if they wanted this to be written in decimal form rather than just in radical form? Well, that's not too hard if you have a calculator. Go to your calculator and figure out what the square root of 3 is. Now, a lot of the calculators they might have something like this on your calculator. Mine does. One button says x squared, and then above it, it has the radical sign, which means that you have to press the second or the second function button and then press the x squared. Okay, so I'm doing the square root of 3, and the number I'm getting, I'm going to go to 3 decimal places, is 1.732. It goes on and on and on for that, but we don't have to go so far, because we want to eventually round off to the nearest 10th. So what I do is I replace the square root of 3 with this 1.732. So for one case, I'll have to do, and I will use my calculator for this, I'll do -5 plus 1.732, which will give me -3.268. And since I wanted to round it to the nearest 10, my first answer would be -3.3. That would be one answer. The other answer I get by doing -5 minus 1.732. And that gives me negative 6.732, which I round off to negative 6.7. Remember, I'm always looking at the number after the 10th place. If it's 5 or more, I go higher. If not, I leave it. And those would be my answers in decimal to the nearest 10th. Again, they might say nearest 10th or the nearest 100th. All it means is then take the radical, stick it into your calculator and work it that way. Occasionally, as I said, that type of question is asked. Okay. I'm not going to ask you, Ismail, I'm going to erase this and I'm going to look at Ismail's question. Okay. What was your question, Ismail?
Okay, so it's x squared plus 15x.
16?
15
Oh, okay.
plus 34 equals 0.
Okay.
And then it says, which number would you have to be added to complete the square?
Okay.
Okay.
So, and you're going to see why I don't suggest using this on this question. I'm going to discuss it. Remember what we're supposed to do. We take the number that's in front of the x term and we divide it by 2. So we do 15 divided by 2. And then what you do is you square that number. Now, you can get your answer into 2 forms. You could change the 15 divided by 2 into a decimal and square it, which will give you the answer 56.25. Or you could have done it in the fraction form. 15 squared is 225 over 4. And that's what you would have had to add. You would have brought this 34 over to the other side. What's wrong with this? What's wrong with it, or it's not wrong, what makes it so difficult is that the number in front of the x is not an even number. Like all the examples that I did, the coefficient of the x was even. So because the first thing you're going to have to do is divide it by 2. And if you have an even number, and when you divide it by 2, you just get a regular whole number and you just multiply by itself. If your number is an odd number, then you're going to get fractions or decimals, and your answer that you're going to have to add makes it a fraction or a decimal. And therefore, for this particular case, I would not like to use the completed the square method. Okay, first of all, did that answer your question?
Yeah, so the number you have to add is 56.25.
Right. I'm going to now show you, so that really leads me into what I wanted to discuss today. The completing the square method, as you noticed on the original question I gave you, worked very nicely when you had 2 things going for you. The number in front of the x squared was 1. It's called the leading coefficient. And the number in front of the x, the coefficient of the plain term, the one that doesn't have a square, is even. In that case, I like to use the completing the square. But if I have a coefficient in front of my x squared, in other words, let's say this would have been 3x squared plus 20x plus something, I wouldn't like to use completing the square. And in this case, I wouldn't like to use completing the square because it makes me go into decimals or fractions, and I really like to avoid those if I can. So what I want to do is I'm going to go and show you an alternate method that can be used to solve any quadratic equation, no matter how it's set up, no matter what, whether it's factorable, it's not factorable, no matter what the leading coefficient is, no matter what the number in front of the x is, all of those, it doesn't matter. This method always works. And this is what's called I'm going to leave this on the board so I can show it to you with this particular example. Again, they didn't ask you to solve this, they just asked you what you would use, so that was okay. But I'm going to show you how to solve this by the method called the quadratic formula. Now, this formula is so important because it allows you to solve any quadratic equation that, no problem. It's so important that you have to know this by heart. They're not going to be given this formula on an exam. You have to know this formula on your own. So let's see what that formula is and how we could solve this question that Ismail had given us. And then maybe I'll go back and show you how it really could have been used even for the one I had just given you as well. Okay, first of all, I have to state what the formula is. A formula is, for example, the perimeter of a rectangle is 2L plus 2W. It's something that allows you to, enables you to get to whatever you're looking to solve. Here's what the quadratic formula looks like. First of all, I have to explain it. We're talking about quadratic equations that are in the form of the x squared, then the x, then the number equals 0. In other words, it has to be in the format ax squared plus bx plus c equals 0. In order to use the formula, we always have to have it equal to 0. And we call the number in front of the x squared, that's what we call our leading coefficient, we call that a. In our particular case, in the question we're doing, my a is equal to 1. You know, you've done this, AC. A is the number in front of the x squared. The c is the standalone number. The b is the number in front of the x, which in our case is 15. And the c is the standalone, the constant. Now, you can't figure out what the A, B, and C are unless you have it in the format ax squared plus bx plus c equals 0. It has to be equal to 0. So that's the first thing. If it doesn't equal to 0, you have to bring everything to one side and make it equal to 0, which is not the way we do the completing the square. It's different. Here is the formula. The formula reads like this. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. It's a pretty complicated formula. You must know it by heart. And when you're using a formula, all you do is you take the particular numbers and stick it into the correct place. So let's see what happens when we do this. Notice we have that special symbol plus over minus because with the quadratic equation, we want to get two answers. And when we're going to actually work it out, we're going to do it once with a plus and once with a minus. Look at what we do. I do negative b. Now my b is 15, so it's negative 15 plus or minus the square root of my b squared, so that's my 15 squared. Basically, I'm taking the letters, taking out the letters and replacing them with parentheses and filling them in with these numbers. Minus 4a, well, my a in this case is 1, times c, my c is 34. And that's all over, the whole thing is over 2 times a, which in this case again was 1. I always like to write out what my a, my b, and my c are first on my side, so then when I go to fill it in, I can just plug it in. It's just a matter of plugging in. Of course, now I have to simplify it. And the hardest part of the simplification is this number that's inside the radical. So let's see how that works out. I'm first going to figure this out. So 15 squared, and I'm going to help use my calculator to help me. So 15 squared is 225. I'm just going to move this up a little bit. So we have the 225 from the 15 squared. And now I have to do minus 4 times, well, I don't have to do times 1, times 34, which is 136. Okay, I'm going to start moving over here. Let's see what I have. I still have that negative 15. Plus or minus. Now, in my square root, I have the 225 minus the 136. So let's subtract it. 225 minus 136 is 89. And it's over 2. Now, I have a radical here. Is 89 a perfect square? No. Is 89, can we break it down into anything? No. If we want to leave our answer in radical form, here it is. The answer to this question would have been negative 15 plus or minus the square root of 89 divided by 2. And I was able to find out this answer by using the quadratic formula. Okay, let me write the quadratic formula on the board on top here, so whenever we want to use it, we'll have it as reference. Notice I make this line long because the 2a is under everything. Okay. The best way to learn this is by practice. So I'm going to do one more example for you. And then I'm going to give you 1 or 2 to try on your own. The first thing I want to do is I want to do the exact example that we had done before using the completing the square method. The reason I want to do it is because I wanted you to decide which method you like better. Do you like the completing the square method, or do you like this formula method? remember, there are cases where you must use the formula. So that original problem that I had given you was x squared plus 10x plus 22 equals 0. And the answers that we had gotten, let me just put the answer. The answer that we had gotten using the completing the square method was -5 plus or minus the square root of 3. I want to show you that using the formula, you will also get this exact same answer. In this case, it's set up perfectly for the formula method because it already has everything on one side equaling 0. And remember, when we have the formula, we want to write out what our A, what our B, and what our C is. So our A again is 1 because there's no number in front of the x squared. Our B is 10, and our C is 22. So sticking it in, that's why I have that formula over there. Sticking in the formula, I have negative B, so that's -10, plus or minus the square root of 10 squared, because it's B squared, minus 4 times 1 times 22. And this is all over 2 times 1. Again, step 1, just take your A, B, and C and stick it into the formula. And as I told you, the first thing we want to do is simplify what's inside of this radical. So I leave this -10 plus or minus, and let's see what we have here. So first I have 10 squared, which that's easy. I know that's 100. And then I have -4 times 1 times 22, and that is not so hard to figure out. That's also easy. Or do it on your calculator. Try to do this separately and then subtract. 100 minus 88 gives me 12. And I have 2 on the bottom. And my last step, once I have the radical all combined, is to try and simplify that radical if possible. Now, the problem that Ismail had given us, we got 89 inside the radical. We couldn't go any further with this, but the 12 over here that we have in this problem could, remember 12 is 4 times 3, so we can simplify the radical 12 into 2 radical 3. So this becomes -10 plus or minus 2 radical 3 divided by 2. And this is, I'm going to give you a quick way to simplify an expression like this, where you have 2 terms on the top, and your denominator is only going to be a single number. You can't just do the 2 into the -10. This is a binomial, so you have to divide the 2 into the -10, which will give you -5, and the 2 into the 2 over here, which will give you 1. In other words, if you want to reduce it, you have to divide that number in the bottom into both of the terms on the top. So therefore, your final answer becomes -5 plus or minus, well, 1 times radical 3 is just radical 3, over 1. I don't have to put it over 1. And again, it's exactly the answer we had gotten before. Advantage of this method is once you know the formula, you can apply it on everything. You don't have to remember all the steps of you don't have to remember all the steps of the completing the square. But the disadvantage is that usually you end up with having to reduce a fraction, whereas in the completing the square method, you do not have to. Okay. I'm going to do one more with you, and then I'm going to give you, well, I take attendance, I'm going to give you 1 or 2 to try on your own. I'm going to erase this one. This formula works on any quadratic equation, whether it's factorable, it's not factorable. There's no exceptions to where it doesn't make sense to use it. You can use it in any quadratic equation. Okay, so here's one that I want to do. It's 2x squared plus 5 equals 3x. We want to solve this quadratic equation. Okay, now the first thing is, if I'm going to be using the formula, I have to have everything on the left side of the equation equaling 0. So this 3x has to be brought over to the other side. And make sure you put the terms in what we call descending order. Start with the 2x squared, because that's your highest power term. The next thing should be the x term, so it's minus the 3x plus the 5 equaling 0. So first make sure your equation that you're going to solve is in this, what we call descending order. And now, since I want to use a formula, I'm going to write out what my A, my B, and my C are. My A is the number in front of the x squared, which is 2. The B is the number that's in front of the x, and don't forget, it's a negative 3. And the C is the 5. If there's a negative, if the number has a negative in front of it, that's part of the coefficient. You have to include it as either the A, the B, or the C. And any of them could be negative as well. Notice this would not be a case where I would want to use the completing the square method for 2 reasons. First of all, the x squared term has a number in front of it. It's not just a plain x squared. So that's one problem with it. That makes it difficult to use the completing square. Also, the number in front of the x is an odd number, which means if you try to use the completing the square, you'd be working either with difficult fractions or difficult decimals. That is something that you avoid when you are using the quadratic formula. Okay. So what do? We take our formula and we fill in the numbers. So it's negative b, so it's negative and negative 3. Notice there are 2 negatives here. Because we're doing negative b, you have to do the negative of the negative 3. Plus or minus the square root. Now it's b squared. Now by b again is negative 3. So I'm going to have to square the negative 3. And be careful, notice I'm putting it in a parentheses to remind myself that the number b is negative 3. That's what I'm going to be squaring. then it's minus 4 times 2, my A is 2, and times 5, my C is 5. And it's all over 2 times 2, again, my A is 2. Okay, now let's start simplifying things. First of all, a negative and a negative become a positive. So this becomes negative 3 becomes 3. Okay, let's see what we're going to have inside the radical. So this, I always like to do it right on top. So I'm working it. Negative 3 squared is negative 3 times negative 3, which is positive 9. And it's minus 4 times 2 is minus 8. Minus 8 times 4 is minus 40. Four times 2 times 5 is 40. And 9 minus 40 is negative 31. And that's all over 4. And whenever the only thing I really want to still do is see if I can simplify this radical. Now I have the square root, I'm just writing it over here. I have a square root of negative 31. Now remember, when you have a negative inside a radical, you don't leave it with a negative. This is the same as the square root of 31 and the square root of negative 1. And remember this, we just learned about this. The square root of negative 1 is I. Usually we put the I in front. This is then becomes I times radical 31. So my final answer is 3 plus or minus I radical 31 all over 4. Now, first of all, this 4, there's nothing, you can't cancel out the 3 and the 4. And even if you could, there's nothing to cancel on this side. Remember, if you wanted to reduce this, let's say you found that everything on top could be divided by 2, you could divide everything by 2. But if you want to reduce the fraction, you have to find something that goes into all 3 terms. You can't just do 2, you have to do all 3 in order to reduce it. But there's nothing to do, so this is your final answer. Again, once you've gotten this far, this is just sticking in, and this is just simplifying the numbers a little bit, combining the numbers. You only last thing is to see if what that radical can be reduced in any way or simplified. Okay, I'm going to put a problem on the board now, and I'm going to see if you can solve that problem using the quadratic formula. And okay, here's a question. I'm going to erase this and put this next one on the board. I will leave the formula on the board, and I'll leave this hint that you should figure that out. We have 2x squared equals negative 4x plus 3. 3, I'd like you to use a quadratic formula to solve this quadratic equation. Okay, and while you're doing that, I'm going to be taking attendance. Jesus. Jackson. Good morning. Tiffany. Kayla. Tishana. Hi, good morning. Dion, I know you're here. Wensley. Tatiana. Hi. Awa. Good morning. Ashay. Eliana. Good morning. Emily. Anastasia. Zenabu. Ismail, I know you're here.
Yeah, I'm here.
Yeah. If I've had a conversation with you, I know you're here. Jaden Jackson.
I'm here.
Hi. Ashiana. Anijah. Thomas John. Paul.
Here.
Hi.
Good morning.
Ashley. Hi. Angelica.
Here.
Hi, how are you?
Hi.
Tayon. Tayon Regist. Akeem.
I'm here. Good morning.
Hi, good morning. Craig Ricketts. Giovanni Rowe. Devonly.
Yeah.
Hi. And Najay Waddell. Okay, I'm still giving you, I didn't see anybody have any answer yet. Do you need more time for this?
I have the answers, but I don't have the square root button on my computer, so it's hard for me to type it on.
Oh,
So it's
Okay.
-2 minus square root of 10 over 2. That's plus or minus.
right, okay, say it again.
-2 minus square root of 10
Plus or minus, right?
Yeah. Over 2.
Okay, let's see if that's what we all come up with.
Okay,
Thank you.
you're welcome.
No. You could also, if you have a square, you could just write SQ, and then I know it means square root.
Okay, no problem.
I know that is a problem. Okay, so let's remember, we want to do, it's a quadratic equation. We see it's a quadratic equation because it has an x squared. We want to use the formula. It has to be equal to 0. So the first thing I have to do is bring everything to the left side. So I'm going to add 4x to both sides, and I'm going to minus 3 from both sides. So that my equation comes out to be 2x squared plus 4x minus 3 equals 0. Again, the formula only works if you have it in the format equaling 0. And now I can pick out what my A, my B, and my C is. My A is 2, my B is 4, and my C is negative 3. Don't forget, since this says minus 3, the negative is part of the C. And sticking it into that formula over there, it's negative B, so it's negative 4 plus or minus the square root. Okay, here comes the biggie. The 4 squared, because that's the B, minus 4 times the A, which is 2, times the C, which is negative 3, all over 2 times 2, because the A is 2. And again, that first thing is to get that number that's inside the radical. Now, 4 squared is 16. And now I have negative 4 times 2. There are 3 numbers to be multiplied. And I keep this negative as part of it. Negative 4 times 2 is negative 8. And negative 8 times negative 3 is plus 24. Be very careful. The most common mistakes made here are when you aren't careful with the signs. So this becomes 16 plus 24, which is 40. So what we have now is negative 4 plus or minus the square root of 40 all over 4. So our first step is plug in the numbers and then do the computation. The thing that we're always left with is to look at the radical and see if it can be simplified. And 40 could be broken down into 4 and 10, and the square root of 4 is 2. So this becomes negative 4 plus or minus 2 square root of 10 divided by 4. And now you look there, here are my 3 terms. 1, 2, this is remember, the number we're going to be looking for is the number in front, because we can't divide a number inside a radical with a number outside. We can only deal with outside. This is like the coefficient. And this number, and I notice that 2 goes into all of them. So I'll divide this by 2 and get negative 2. I'll divide this by 2, that'll of course give me 1. And I'll divide this by 2 and it'll give me 2. Don't forget, I can only reduce it. I can only simplify it if I have a number that goes into all 3 of the terms. So now I see what I'm left with is negative 2 plus or minus 1 times radical 10, which is radical 10, all over 2, which is exactly what, I'm trying to think who
Ashley.
was Ashley, right?
Correct.
Right. Plus for you, that was great. Thank you. Shall we do one more? Should we try one more like this, just as a good practice? Notice one thing you have to be careful about is this, the main thing is to be careful with this radical. If it's a negative, it means you're gonna have an answer with an I in it. If it can be simplified, you've got to simplify it so that your final answer comes out. And again, you could write this separately as 2 plus square root of 10 over 2 and 2 minus square root of 10 over 2. You could write it as 2 separate answers, but the more efficient way to do it is to use this plus minus. Okay, here's one more question to do. Let's see if you can solve this. X squared plus 5 equal 2x. I'm going to give you a few minutes to do that. And you can decide which method you want to use to do it. I am actually going to do it using the formula method because I just want to make sure we have practice. But if you have another method that you think could work and it works good, then you can do it. Okay, so you're on your own now. Yes. I'll give you one more minute and then we'll do it together. Okay, Ashley. Well, we'll see if you're right or not. Okay, we have an answer. Obviously, it's a quadratic equation because it has an x squared. And we want to get it equal in the standard format where we have everything on one side equaling 0. So I'm going to take this 2x and bring it to the left here. And I'm going to arrange the terms in order so that I have x squared minus 2x plus 5 equaling 0. Now, if I look at this, I really could have used the completing the square method because the number in front of the x squared is 1, the leading coefficient is 1, and the number in front of the x is even. It can be divided by 2. But as I said, I wanted to do this using the formula method, so let's go with the formula method. The a, again, we know is 1, the b is -2, and the c is 5. So sticking it into the formula, we have -2. Don't forget, when the b is negative, you end up with 2 negatives, plus or minus your square root of -2 squared minus 4 times the a, which is 1, times the c, which is 5. And that's all over 2 times 1, because the a is 1. Just sticking it into the formula. The first step is just replace the numbers. The letters over there were the numbers. That's why if I have the letters written down right here, it's very easy to do. Okay, now we're going to combine things and get things a little bit simpler looking. -2 becomes a +2. Okay, here's my big work. I have to do this in steps. -2 squared is -2 times -2 is +4. And then I have -4 times 1 times 5, so that's -20. So this combines, don't try to do this all in, and don't set it, I think it's better to do it not in your calculator unless the numbers are really hard. But then do it in 2 separate pieces. The square the number, and then do the -4 times the a times the c. And 4 minus 20 is -16. And that's all over 2. And the next thing I look at is this radical, the square root of -16, which can be broken down into 16 and -1, so that it becomes 2 plus or minus, the square root of 16 is 4, the square root of -1 is I, divided by 2. And notice I have my 3 terms, the 2 terms on the top and the one on the bottom, and they are all divisible by 2. So I can divide this by 2 and get 1, this by 2 and get 2i, and this by 2 and get 1, so that my final answer becomes 1 plus or minus 2i. Or if you wanted to write it separately, 1 plus 2i as one answer, 1 minus 2i as your other answer. see. Okay. Tashana, did you see you have to simplify that square root of negative 16? And Ashley, yeah, that was excellent, yes. Okay. Great. Okay, so I think we're in a very good position here that we can solve quadratic equations just like you can solve any linear equation. You can now solve any quadratic equation. So if equation has no exponents, which makes it a linear equation, you just go about it the regular way, bringing the x's to one side, the numbers to the other side, etc. If you have a quadratic equation, if you have an exponent of 2 in your equation, you can solve it. Again, you could try factoring it, or you can use either of the two methods that we just learned starting Thursday, the completing the square method or the formula method, but any quadratic equation is now solvable by us. If you recall, when we did linear equations, after we did solving of linear equations, we talked about graphing of linear equations. And remember, we reminded ourselves that we called them linear equations because they were, when we graphed them, we got straight lines. So now we're going to talk a little bit about what happens when you want to graph quadratic equations. What does a quadratic equation look like graphed? And we're going to see anytime you have an x squared or a y squared in your equation and you want to graph it, you're not going to get only one type of pictures. There are actually 4 different types of graphs that you could get. Today, we're going to talk about the first type of graphing that we can have with quadratic equations, where if we have an equation that looks like this, y equals ax squared plus bx plus c. In other words, instead of having it equal to 0, when we're graphing, we need not just an x, but we need a y as well. What happens where instead of this 0, we have a y? What is that going to look like graphically? As I said, when we finish this section on graphing, we will see, as I said, there are 4 basic shapes that we could get. This type of equation, where we have an x squared, but notice we do not have a y squared, it just equals y alone. The x is squared, the x is quadratic. We have an x squared, we might even have an x. But again, we're looking at the highest exponent of the x is a 2, but the highest exponent of the y is only 1. In that case, we get a graph of something that's called a parabola. And a parabola is basically a U-shaped graph. It's not really exactly U because the sides are not going straight up, they're sort of coming out at an angle. But the basic shape is U. Sometimes it's a U that opens up, and sometimes we have a U that opens down. In other words, an upside down U. And if you notice, if you have, and this is true anytime you have this U type of shape, you have a point that is like essential because it's the point where the graph turns around. look at, if you're traveling along this graph, let's say going up a hill, going up the hill, up the hill, up the hill, you get to this point, and now you're suddenly going down the hill. This is sometimes called a maximum point. It's the top of the hill. Or if you're going this way, first you're going down, 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 down the hill. You get to this point, you're at the bottom of the valley, and now you start going up. We call this point, it has a few different names. One name for it is a turning point. Well, it's obvious why we're calling it a turning point, because it's basically where the graph is turning around. Notice we don't have a straight line now. We have something that's curvy. And this curve starts going from, it either can start over here on the left side going down until it comes around to here and then starts going up. Or vice versa, it can start all the way at the bottom and go up, 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 up until it gets to this point and turns around. Another name for that point is also called the vertex. We could actually specify the turning point on this graph happens to be a minimum point. So sometimes it's called the minimum point because it's the lowest point. The turning point on this graph happens to be the top of the hill. It's the maximum point. It's the highest point. Notice when I use the word turning point of vertex, I'm not specifying is it a high point or a low point, but when I use the term minimum point, then you know that you have like a U-shaped opening up with the bottom. And when you have a maximum point, you have an upside down U-shaped, and it's called the maximum point. Actually, even before you start graphing, you can tell if what you're going to have is a minimum point or a maximum point by looking at the value of A. A is the coefficient of the x squared. If A is positive, you have a opening up parabola. In other words, you have a minimum point. Look at how it's positive, so it's smiling. Over here, if your A is negative, let's say it's y equals negative 2x squared, the number in front of the x squared is a negative, then you have a maximum point. Your graph is opening down. Again, this looks like a frown, so negative people frown and positive people smile, so that's a good way to remember it. So that's number one. We can look at our equation and tell right away what the graph is going to look like, basically in terms of is it going to be an opening up parabola or an opening down. I would say the other thing that's very important to know would be to know where this vertex is, because if I know that I have a parabola that opens down and I know where its vertex is, I have a very good picture of what that graph is going to look like. And actually, there is a formula that allows us to find the vertex. So let me give you that formula, and then I'll show you how it applies to a particular example. In order to find the vertex of the parabola, you figure out x equaling to negative b over 2a. In other words, you're going to know what this a is, you're going to know what the b is, you're not going to know what this c is. X equal negative b over 2a will give you the x value of the vertex. But the vertex is a point. In order to find the y value, you're going to have to stick it into the original equation to figure out the y value. Let me give you an example. suppose I gave you y equals x squared minus 6x plus 5. Now remember, this is not a quadratic equation because we don't have it equal to 0, we have it equal to y, which means we know we want to graph it, and the shape we're going to get is a parabola. Now let's, like we did before when we were using the formula, let's write down what our A, our B, and our C is. Our A is the number in front of the x squared, and that's obviously 1. There's no number there, so it's understood to be 1. Our B is -6. Our C is 5. First of all, I know that the A is positive, which means I have a parabola that's going to be opening up. It's going to look like a smile. It's positive. How do we figure out the vertex? So I do x equals -b. So it's -6. Be careful, just like we did before. When you have this -b, if the b is negative, you end up with 2 negatives over 2a. So 2 times 1. Now this is not as hard as a formula because it's just a couple of numbers. A negative and the -6 is +6 over 2. And 6 over 2 gives me 3. Now remember, I'm not finished. This is not, 3 is not the vertex, because the vertex is a point, it needs a y value as well. So in order to find the y value, we go back to our original equation, the y equals, and replace the x now with this number 3. So it's going to be 3 squared minus 6 times 3 plus 5. Okay, so let's figure this out. 3 squared is 9. -6 times 3 is -18 plus 5. So this is 9 minus 18 is -9. -9 plus 5 is -4. And it turns out then that the vertex of this particular parabola is the point 3, that's my x, minus 4 is my y. So finding out the parabola, the vertex of the parabola, and finding out whether it opens up or down is pretty straightforward. If I were going to graph it, here's what I do. I first find where the vertex is, which is 3 to the right and 4 down. So it's right here. And I know my parabola is going to be going like this, going something like that. Not a very good picture, but at least if I were doing a multiple choice and I had to pick it, if I could pick, and if they all had different vertices, or some were up and some were down, I'd know what to pick. But obviously, I would like something a little bit, and I'd like a little bit more information. And there are 2 other things that we usually figure out when we're trying to graph a parabola. Basically, when we're trying to graph any kind of figure on the Cartesian coordinate system. Remember, and we did it even when we had lines. It's finding the intercepts. This is something that's usually very important to do as well. Again, when we're trying to graph a parabola, the first thing is to look for that vertex. But let's see if we can find, in addition, the x and y intercepts. Now, I'm going to start with the y-intercept because that's usually the easier one to do. Remember, if you want to find, we did this before, if you want to find a y-intercept, in your equation, put x equal to 0. So if I do that, I'll have y equals 0 squared. Remember, I'm replacing the x with 0, minus 6 times 0 plus 5, which ends up being, well, this is 0 and this is 0, just 5. In other words, the y-intercept is a 0.05. I'm going to erase this over here, because now I'm going to be able to do better. You might have noticed that actually the c is the y-intercept. And that is always the case, because if you have your ax squared and your bx and you're putting 0 for your x, all you're going to be left with then is the c. So this was our vertex, and this is 1, 2, 3, 4, 5. Here's our y-intercept. When x is 0, y is 5. How do we find the x-intercept? Well, similarly, we set the y equal to 0, which means over here, I will, instead of getting y equals x squared plus minus 6x plus 5, I'll get 0 equals x squared minus 6x plus 5. This happens to factor because if you notice, the AC is 1 times 5, which is 5, and the B is negative 6. So two numbers that are going to multiply to 5, but when we add them are going to give me negative 6, is going to be negative 3, negative 5, and negative 1. This is going to be x squared minus 5x minus 1x plus 5. Again, if you don't like doing it that way, of course, you can use the quadratic formula or the completing the square on this one. So this gives you x times x minus 5 minus 1 times x minus 5. So it factors to x minus 1 and x minus 5. Notice that makes sense because negative 1 times negative 5 is positive 5, and negative 1 plus negative 5 is the negative 6. So that we get here, I'm going to go over here. And I get my x minus 1 equal to 0, which brings the x equal to 1. So 1 x-intercept is the point 1, 0. And the other answer, x minus 5 equals 0. I bring the 5 over, gives me x equals 5. So my other x-intercept is 5, 0. Remember that you can only have one y-intercept, but you could have, and very often do have, 2 x-intercepts. One is here at 1, 5, and the other one here's 1, 2, 3, 4, 5. Here's 5, 0. And now I can really draw a nice graph. Out a little bit more like that. And that's what my parabola will look like. Okay, this is where we're going to start next time. Next, I'm going to give you some homework on solving quadratic equations using the formula. Don't forget that you have a test on Delta Math that has to be completed by Thursday morning. Okay, so a bunch of people have already done it. If you haven't done it yet, please make sure you do it in time. All right, and I'm going to end the set, unless there are any questions, I'm going to end the session now.
Okay, Professor. I noticed you took attendance, but I didn't hear it. I think I might have stepped away from my phone, but I'm here. I was here.
Who was that? Who am I?
Theon,
Yeah, I know, as I was saying, I said, I know Dion is here because I saw you.
right, okay. All right, so you have a good day. I see you, Thursday.
Okay,
All right,
have a good day and I will see you on Thursday. We're getting to the lab, we have like 4 weeks left to class, so we're getting towards the end of the term.
yeah,
Yeah,
all right, have a good day.
Professor,
bye-bye.
have a good one.